This is day 44 of coding every day until I hit 1K subs. Today I worked on a couple of my ongoing projects, focusing on scripting for this very series and enhancing a browser extension. Then I jumped into 3 LeetCode problems, one of which took a neat mathematical approach to solve efficiently. Let's get into it. This is day 44 of coding every day. Today I made some refinements to the automation script that helps generate content for this coding everyday series. The main change involved fixing up prompts to ensure the generated material is more aligned with what I need. It's all about making the workflow smoother. I also spent some time on a browser extension I'm developing, called the AI Studio Copy button. This extension is designed to improve the user experience on Google's AI Studio. I pushed a version fix, renamed the project for clarity, and added a feature for a static input placeholder, along with improving the stability of the copy button itself. So what does it do? The main features include moving the copy button to a more convenient location, ensuring that when you copy text, it preserves all the markdown formatting like headers and code blocks. A new addition is the static input placeholder, which just keeps the input field saying, type something, instead of changing dynamically. And, of course, it's designed to be easy to use, working automatically on the AI Studio website. Under the hood, the extension uses a content script that interacts with the Google AI Studio page. It watches for changes on the page to add its custom copy response button to messages. When you click this button, it grabs the formatted content and puts it on your clipboard. It also finds the main input field and sets that static placeholder I mentioned. Alright, after those project updates, I jumped into some LeetCode. First up was problem 2900. Longest unequal adjacent group subsequence Y. Spoiler alert. The problem asks us to select the longest subsequence of words, such that any 2 consecutive strings in our selected subsequence have different corresponding group values from an input groups array. Essentially, we want an alternating sequence based on these group IDs. This solution iterates through the input groups array. It always includes the first word. Then, for subsequent words, it checks if the current group identifier is different from the previous one. If they differ, the corresponding word is added to our results subsequence. This is a greedy approach that directly builds the longest alternating subsequence. The time complexity is order n, where n is the number of words, and space complexity is also order n to store the resulting subsequence. Next, I tackled problem 3335. Total characters in string after transformations Y. Spoiler incoming. We're given a string S and a number of transformations T. In one transformation, by Costco-Leckley becomes TJ, and every other character becomes the next character in the alphabet. A. Costco-Leckley becomes. We need to find the total length of the string after T transformations, modulo 10 to the power of 9 plus 7. This solution simulates the character transformations iteratively for T rounds. It maintains an array CNT to store the counts of each of the 26 lowercase English letters. In each round, a new counts array NXT is computed based on the rules, contributes to and in the next round, and every other character contributes to char plus 1. The counts are updated modulo 10 to the power of 9 plus 7. This process repeats T times. The time complexity is order T, as it iterates T times with constant work, 26 operations, inside the loop. Space complexity is order 1, as it only uses fixed size arrays for character counts. And for the third LeetCode problem of the day, it was 3337. Total characters in string after transformations 2. Spoiler warning. This one is similar to the previous, but the transformation rules are more complex. Each character is replaced by the next nums, consecutive characters, wrapping around the alphabet if needed. Again, we need the total length after T transformations, modulo 10 to the power of 9 plus 7. The nums array has 26 elements, 1 for each letter. This problem involves transformations over many steps, hinting at matrix exponentiation. This first part of the code sets up the tools, a mat class for 26 by 26 matrices, an identity matrix function I, and a quickmul function for matrix exponentiation by squaring. These will allow us to calculate the effect of T transformations efficiently. The core idea is to represent one transformation step as a matrix T. Each entry T at row J, column I stores how many characters J are produced from one character I. The nums array defines these transitions, with wrapping around the alphabet. After constructing this base transformation matrix T, we use quickmul to compute T raised to the power of T. This new matrix represents the total effect of T transformations. Finally, we multiply this resulting matrix by a vector of initial character counts from string S to get the final character counts and sum them up. The time complexity is dominated by matrix exponentiation, which is order L cubed times log t, where L is 26, the alphabet size. Space complexity is order L squared for storing matrices. And that's a wrap for day 44. We touched on some project development and then dove into 3 LeetCode problems, including one that required some matrix magic. If you enjoyed this or found it helpful, please do like the video, subscribe if you haven't already, and drop a comment. Maybe let me know which problem you found most interesting, or if you have a different approach. You can also support the channel over at buymeaboba.com, link in the description. Thanks for watching, and I'll see you tomorrow.